All right, example 2. Notice the difference in the structure of the problem. The last problem had a radical object being subtracted by radical object. Now we got radical object times radical object times radical object. This is all multiplication. And the radicals are square root of 2, the square root of 12, and the square root of 3. Now, if I were to multiply 2, 12, and 3 together, I get 72. All right, let's just imagine we got 72 here. Don't do this, but let's imagine we had 72. And let's say my first breakdown, I don't know, let's go 6 times 12. And then 6 is 2 times 3, right? Now let's just bring the 12 down because I don't feel like breaking it down here. Notice that in the prime factored form of 72, I'm going to get to a point where it's 2 times 3 times 12 maybe. It's a little inefficient to get there, but you notice it's already part way there. All right, so my point is this. Instead of multiplying this times this times this to get this number, just to go ahead and break it all the way back down, it's already partially broken down at this point, right? So what I want to do on this is I'm going to go start at 2 times 12 times 3. That's what's underneath the radical. And again, my goal is to pull out perfect square factors to find these pairs of prime numbers that are in there. So if I keep breaking it down, 2 is already prime, 12 is 2 times 6, and 3 is just 3. Then some new numbers here that multiply to make 3. All right, 2, 2, 6, 3, and then of course 2 is prime, and 2 is prime, and 6 is 2 times 3, and 3 is just 3. And just like that, we get this number broken down completely. So instead of multiplying all this out to some number just to break it all the way back down, again, it's already partially broken down, just break it down the rest of the way. That's what goes underneath my radical. 2 times 2 times 2 times 3 times 3. Then the other numbers that are outside, the coefficients, 3 is being multiplied by 4, which is being multiplied by 2. Those numbers are already outside the radical. They should be multiplied together to get a single number. So 3 times 4 is 12, times 2 is 24. So that'd be my first step in this problem. If I got just a bunch of radical objects being multiplied together, the non-radical parts multiply to make a new outside number. The underneath the radical parts are going to be broken down the rest of the way to all prime numbers. Once I've done that, any pair of prime numbers inside equals a perfect square. I get to pull one of those out. So a pair of 2's equals 4, the square root of 4 is 2. Thus, a pair of 3's is 9, square root of 9 is 3. So every pair of primes is equal to a perfect square. Those come out. This other 2 didn't have a pair. We paired up these 2. This one got left alone. So the square root of 2 stays underneath the radical. And these 3 numbers outside, 3 times 2 times 24 makes 144. And that is the simplest version of that number. I expect in this class, anytime you have a radical answer, and you're expected to leave as a radical answer, if it says give the exact answer, this is the exact answer. When it gives you a radical, I expect the radical answer to always be simplified completely. Don't give me 24 times the square root of 72. Give me 144 times the square root of 2. Always simplify radicals to the simplest form possible whenever I ask for a radical answer in this class.